Welcome everyone. Welcome to this webinar being organized by British Lisa Center for Data Science and Artificial Intelligence. I'm Ankur Sinha, and I'm very happy to introduce you to Professor Anuj Kapoor. The topic of the webinar today is multi-objective personalization of the length and skippability of video advertisements. Very quickly, a bit about Professor Anuj Kapoor. He's an assistant professor of quantitative marketing at IIMA Ahmedabad. His research interests are in the economics of digitization, artificial intelligence, privacy, and digital platforms. His research focuses on understanding how big data and AI shape consumer welfare and digital markets. He works closely with firms to suggest to them more ways to become data-driven. He has ongoing collaborations with various tech startups in India in the digital media, finance, and health tech space. Anuj completed his PhD in business administration from the University of Utah, and after his doctoral studies, he worked in the data science space in San Diego, USA. At IIM Ahmedabad, he teaches electives on AI and marketing, privacy paradox, data, artificial intelligence, and digital platforms, monetizing AI and technology. Over to you, Arun. We're looking forward to your talk.
Thank you for the kind introduction. So what I'll do is I'll share my screen. I'll get started from there. Okay, I'm assuming my screen is visible. Okay.
It is, yeah.
Okay, awesome. So this is joint work with Omid Rafian at Cornell, and this is work in progress. So in case you have any questions, any feedback, please let me know. Happy to incorporate, because this is still in another round of review, so you have. Okay, so I'll get started with the context here. Video advertising on content streaming platforms has become one of the dominant channels for advertisers. Digital video advertising, it's estimated to surpass $50 billion in advertising spend in 2023. So video advertising is big, especially in the digital marketing space. Digital video ads have two main features. First is length. So you must have seen certain long video ads which don't stop. And then you have skippability, which is an important feature where you can skip an ad if you want to. Right? So this length and skippability, also there is an interplay that goes on. So longer ads are more informative, and they also result in ad avoidance. Right? So people don't want to see longer ads, even though they can be more informative, but they can also induce ad avoidance. So you start avoiding if you see that an ad is going to be a long one. To counter that, platforms have come up with skip button. This skip button can sometimes act as a screening process that filters users who are uninterested in the ad content. However, advertisers sometimes want to reach uninterested users, and skippability can actually hurt this goal. Right? From the monetization perspective, even if you know that the user is not engaged, you still want to reach out to those users. But if you add a skip button, it can hurt this goal of reaching out to these uninterested users. Right? So this strange interplay between length and skippability of ads is something that we are going to explore in this project. So two ad formats. There is one ad which can be non-skippable, but it's short. So very quickly it passes, and you see a lot of those ads around platforms, content platforms, as well as on YouTube. And then there are longer ads, but they come up with a skip button. So they are skippable, but they are long. So for platforms, it is still not clear which one of these two ad formats is optimal. So from a platform perspective, the platform has multiple objectives. Right? So the issue here is that you want people to watch the video, but you also want people to watch the ad before the video. Right? The only issue is that if the ad is longer, people are likely to many times skip watching the content behind it. But as a platform, my objective is that people consume both ad as well as video. So objective of higher engagement with both the sponsored ad content and the organic video content are in direct conflict with each other. Why? Higher ad engagement can actually substitute for the time spent on videos. So if you assume that you are new to the platform and you get there and you see that if the ads are longer, people are likely to drop off and they won't consume the content which is behind that ad. But on the other hand, a lower ad avoidance can positively affect the engagement with the video content. So if people like the ad, they are also likely to consume the video content behind that ad. So it can go either way. With this project, we tackle some of these research questions. First is, how does a skippable long ad format perform in terms of ad as well as video consumption, which is behind the ad, compared to the non-skippable short ad format? So to what extent is there a substitution pattern between the ad and video consumption in content streaming platforms? So the first question we want to tackle is, which one wins? Are people likely to opt for a skippable long ad versus a non-skippable short ad? And if there is substitution that happens, that is what theory suggests, is there a pattern between ad and the video consumption in content streaming platforms? So that's question number one. Question number two is there any heterogeneity in the effect of the skippable long ad format on both ad and video consumption outcomes compared to the non-skippable short ad format? So do we see any heterogeneity? Do different set of users respond to these ads differently? Thirdly, how can a platform develop a set of personalized policies that perform well in terms of multiple objectives? So here the objectives are ad consumption as well as video consumption, right? And what are the gains of multi-objective personalization? So these are some of the questions we try to answer in this research. To answer these questions, three set of challenges are there. First is to compare the performance of a skippable long ad with that of non-skippable short ads. We need to have exogenous variation in users' assignment to each condition. Otherwise, the issue is the ad that we see on the platform, that's a function of who we are. So if you consume a lot of dog content, you're likely to get a dog ad, right? Which is related to dogs. Now, the problem here is if that is the ad that you like, you're likely to watch that ad irrespective of that is long or short. So this endogenous getting into one set of ad is something, so we need an exogenous variation in users' assignment to each ad condition. Secondly, to quantify the heterogeneity in the effects of these ad formats. So to quantify the heterogeneity, we need a method that can help us reliably estimate conditional average treatment effects. So given a set of covariates, how different set of users are going to respond to these kind of ads, whether these are short ads with no skip button or these are long ads with a skip button. Thirdly, to perform multi-objective personalization, we need a framework that finds a set of personalized policies that perform well on both dimensions. When I say policy, we are talking about offline policies, which is what should be that heuristic that you apply, or what should be that treatment that you give to an individual who comes to your platform. Should you show that individual a longer ad with a skip button or a shorter ad without a skip button, keeping in mind that you want to increase both the ad as well as the video consumption, right? And that's where the multi-objective optimization comes into play. In particular, our goal is to find the Pareto frontier of the policies in terms of both ad and video consumption objectives. That is a set of policies that are not dominated by any other policy in both objectives, which means that the policy that we choose, if we choose that this individual should be provided with a long ad with a skip button, there should not be any other policy that will maximize the objective, which is video as well as ad consumption. So that's essentially what we want to do. But these are the three set of challenges and how we tackle them. So for first, performance comparison. As I said, we need an exogenous variation in the ad delivery. So for that, we partner with a video advertising platform, vdo.ai. We assign users to 3 experimental conditions. We run a large-scale field study on real consumers, and these consumers are put into 3 different buckets. The first one is a skippable long ad of a single product that is 60 seconds long, right? So certain set of users go into this bucket. The second set of users go into a non-skippable short ad of the same product that is 15 seconds long. So it's a short one, but you cannot skip it. And the third is a no ad condition where the user watches the video content without having to watch an ad. So that serves as a baseline, right? The 2 ad versions are differently sized cuts of the same raw footage, which are used as the 2 versions the advertiser used, so that the storyline and what we show to the user stays constant. So all other observables related to the ad stays constant. We run the experiment for 4 days on over 50,000 users, and the experimental variation in assignment to each ad format allows us to isolate the causal effect of these ad versions on different outcomes, right? It also enables us to isolate the substitution between ad and video consumption as the assignment to the treatment exogenously shifts ad consumption, right? So 4 days, 50,000 users. Challenge number 2 was heterogeneous treatment effects. So we want a reliable estimate of heterogeneity. And for that, we use causal forests to estimate conditional average treatment effects on both ad and video consumption outcomes, right? So what will happen is, after this exercise, we'll have a personalized policy for each of these individuals, where what should they be allotted to, conditional on what we know about them. Challenge number 3 was on designing a multi-objective personalization framework. For that, we theoretically link the Kate estimates, that is the conditional average treatment effect estimates, to both objectives. And we actually propose 2 algorithms. First is a greedy front elimination algorithm, and I'll discuss the heuristic in a few minutes, and parameter agnostic scalarization algorithm. Right? And that's what we do. Contribution to literature. So substantively, we document the interplay between ad and video consumption. How there is an ad and then there is a content behind that ad, how these two feed into each other. So we causally establish the substitution pattern between these 2 consumption outcomes. From a methodological standpoint, we propose a framework for multi-objective personalization and design 2 classes of algorithms. From a managerial perspective, our multi-objective personalization framework can be widely applied to other settings where there is a conflict in treatment effects on multiple desired outcomes. So you want one outcome and you want the other as well, but both the outcomes are not in sync with each other. If one increases, the other decreases. Our assumption is that this framework can be applicable to even those settings. In a lot of freemium settings, for example, say newspaper, right, where there is paywall. Now, related literature. So broadly, our paper relates to the advertising literature in marketing and economics. More specifically, our work examines the role of ad formatting in shaping user behavior. The question of how to optimally use different variations of the same ad has long been of interest to advertisers and marketers. And if you see, there is a ton of research on importance of features such as skippability, ad length, and the presence of timer in context of advertising. Secondly, there is literature on interplay between sponsored and organic content and different aspects of ad avoidance, quantifying the audience loss caused by ad avoidance, linking ad avoidance to sales, and also proposing market design solutions to account for audience externalities. These are some of the papers that fall in the realm of what we are trying to study here. Next, on the methodological front, our paper relates to the literature on multi-objective optimization, especially in terms of bandits as well as reinforcement learning. Lastly, our work also relates to literature on personalization. And tons of papers have been written now in economics as well as in marketing that give a causal lens to machine learning algorithms that have been traditionally used for personalization tasks. Experiment. So what I'll do first is I'll discuss the experiment, then the results of that experiment, then we'll discuss heterogeneity using causal forest, and then finally we'll look into the personalized policies that we come up from the gate that we recover from the heterogeneity. So as I had mentioned, for the experiment, we partner with vdo.ai. So the context is video advertising industry, which is based in India and the US. So vdo.ai it serves clients both in India as well as US, and it provides video services to publishers worldwide. And since its launch, Video has attracted many large and medium-sized media publishers, and they'll use this company's technology to serve video content and video ads on their platforms. Video ads, if we take a step back, can actually be put into three different buckets. Pre-roll, which means the content will be played, and before the content can be played, there is an ad before that content. The second one is mid-roll. That is, you are watching the content and suddenly in between the ad plays out. And then post-roll, you are done with watching the content and after that the ad comes. For our setting, we focus on pre-roll ads. That is, you have to first watch the ad and then only you can move to the content. So we are fixing the pre-roll ads as the context of our study. So if you look at the experiment design here, we have no ad condition, where the user does not need to watch an ad to start consuming the organic video content. We have non-skippable short ad condition, where the ad shown is a 15-second long ad of the boat's watch extend product. So we keep the product constant here, and that is boat and its watch, the new version of the watch, and same storyline, but we have a skippable long ad, which is 60-second long, but same boat product. The only thing is you can skip this long ad after 5 seconds. And this is how the screenshots of both the ads look like. If you see here, this is non-skippable short, and this is for skippable long, but the context, the storyline remains the same. Now, schema of our experiment. So we have step 1, where a user clicks on a video to watch, right? So you choose to opt for a video that you want to consume as a user. Then user is assigned to an experimental ad condition. Now this is random, right? You can get assigned to any of these 3 conditions if you see here, right? So either you can be in the skippable long ad or you can be in a non-skippable short ad condition. Then happens step 3, where user decides how much of the video to watch. The fun part is all these we measure because we are working directly with an ad exchange. So irrespective of which website you are in, we'll be able to recover how you are engaging with that content on the platform you are. Right? So experimental data, we have access to pre-treatment variables. So we have access to users' IP address, time of the day, date, city, country. We have actually minute latitude, longitude as well, and the operating system of the device that the user is leveraging. So these are the pre-treatment variables before the treatment comes into play. Then we also have treatment variables where we have a dummy for the assignment condition, whether the user is assigned to a no ad condition, to a non-skippable short ad condition, or a skippable long ad condition. We also have outcome variables. So as I had started with, the platform has 2 objectives. They want you to consume the ad. They also want you to consume the content behind the ad. So we measure both ad performance as well as the video engagement matrix, right? So I'll quickly start with the summary statistics of the pre-treatment variables. So if you look here, there are a total of 956 cities in our data. However, over half of the observations are from Mumbai. There are many cities with only 1 observation in our data, and vast majority, 99.56% of all observations come from India. And Android operating system is the most common operating system in our data with around 80% of the total traffic. I can see a question somewhere. What goes behind choosing the product? A product like board might have strong fans as well as many who don't know and many ambivalent. But choosing a universally known, yeah, that's a great question. Why we choose both? Because we knew that we are going to serve our publishers which are based out of India. So we actually ran a pre-test. And what do we mean by a pre-test? We showed a representative sample of users, 5 different products, in terms of how aware they are of the product, how likely are they to purchase the product. And in that, both is one of the products that stood out. And that's why we are using both as the ad. Right? But that's a great question. I mean, it can have its own drawbacks, but we did do a pre-test. So that's the pre-test data with us. Empirical analysis, average treatment effect. So for inference, we use the common assumptions in the causal inference literature. That is, you need to have overlap as well as unconfoundedness. Now, that is satisfied by design. Since we have a randomized controlled trial, and the third assumption is Sutwa, which is the stable unit treatment value assumption. And there is no interaction between the users, right? And the treatment received by all users in the same treatment condition is identical. So no multiple versions of the treatment. And that's how even the third treatment condition is of the causal inference is satisfied. So as a next step, we calculate average treatment effect, right? And these are the description of the outcome variables. So the prior summary I've shown you was on pre-treatment variables. These are the outcome variables. Now what we measure ad-related variables, we measure video-related variables. So for ad-related variables, we have ad consumption. So this is numerical variable indicating how much ad content the user has consumed in discrete 15-second units, right? The next is second 15 complete. That is, it's a binary variable indicating whether the user has reached the 15th second of the ad or not. Then we have ad complete, which means it's again a binary variable, which suggests whether the user has completed watching the entire ad or not, right? And then we have ad click, whether the binary variable of whether the user has clicked the ad or not. Just one caveat to keep in mind, video advertising is meant for brand awareness, right? So click and call to action is something which is not that particular, especially for video advertising campaigns. So the focus mostly is on creating awareness. And once a lot of money is spent on awareness, then people go for call to action. And that is the same motive behind our campaign. On the video matrix, we measure numerical variable of how many quarters of the video have been watched by the user, right? So we don't know the exact seconds for which the user has watched the video, but we do know how many quarters of the video have been watched by the user. We also have video start. So binary variable, whether the user chooses to start watching the video content or not. We have whether the user has reached quarter 1, 25% of the video, quarter 2, 50%, quarter 3, 75%, and quarter 4, which is 100% of the video. So all these engagement metrics are what we can measure of our outcome variables. Now, I can see a question here. Was the video content after the ad play also kept constant? So that's a great question. No, because you choose to consume video content. So it's a real website. I cannot force you to watch a video. So the video is something that you choose, but the ad remains the same. Okay, average treatment effect on ad consumption. So if we just take a step back and look at the theoretical perspective, it is not clear which of the ad format leads to higher ad consumption, which is measured by time spent viewing the ad content. So a longer ad has an inherent advantage as it can be consumed for a longer time. So because people have inertia and there is a longer ad, longer time to interact with the user, there is a high probability people should watch longer ad. But then the ability to skip the long ad after 5 seconds may result in lower consumption because suddenly you come up with a skip button and that gives consumer the power to actually skip it, right? So it can go either way. So we are not sure the effect of ad format on ad consumption is actually an empirical question, and we test it in a real world setting now. So what we see this. So if you look at the results here, the average consumption of a skippable long ad is significantly higher than that of a non-skippable short ad, with the average treatment effect of around 0.90. And if you multiply it by 15 seconds, that's like 13.50 seconds. So users spend greater time viewing the skippable long ad in our study, right? And this 13.5 seconds is actually approximately equal to the length of the short ad in our study. So if I have to sum it up, the main results of this experiment, the user are spending greater time viewing the skippable long ad than our non-skippable shorter ad, right? Now, completion rate of the first 15 seconds. Only 1.9% of the users in the skippable long ad condition skip the ad before the second 15 checkpoint. So if we look at whether the user crosses the 15 seconds of watching the ad, because that is where the shorter ad ended, we see that only 1.9% of 50,000 users actually skip the ad, and 42% of them completely avoid the ad, right? Theoretical reasoning, skippability actually option reduces immediate ad avoidance. So if it's a long ad, it's likely to create reactance in the minds of the user, or you are forcing me to watch an ad. But if I give you a skip button, it gives you that sense of power, freedom, right? Control. And then you actually go along with the watching the ad content. And that's what we see in the real data as well. So more generally, this finding indicates that many users actually receive a positive utility from consuming the skippable long ad, right? So there is tons of literature on ad avoidance, but then here we also see that certain set of users, not all, have a positive utility from consuming the skippable long ad, right? Now, to test the extent to which users exposed to the short skippable long ad continue watching the ad, we compare the complete ad rate for the two set of ads, right? And so theoretically, we expect a higher ad completion under non-skippable short ad, because shorter ads are easier to complete, right? So we are not consuming the, not looking at the time spent. We are looking if you complete the ad or not, right? So shorter ads are easier to complete, and the inability to skip forces users in this condition to complete the ad in order to watch the organic video content, right? So going with that logic, we should see that non-skippable shorter ads should be completed more, right? And that is what we see. 53.5% of non-skippable short ads are completed, whereas only 21.3% of skippable long ads are completed, right? Now, if we'll see, skippable long ad format in our study results in higher ad consumption than that of non-skippable short ad. This is an important result from a revealed preference point of view, as users in the skippable long condition have the choice to skip the ad at any point 5 seconds into consuming the ad, right? And together with the high rate of abandoning the session, our results indicate that the consumption utility of the ad in our context is largely heterogeneous, which motivates our studies focus on personalization. Now, this was ad consumption. Now let's see what happens to the video consumption. The theoretical standpoint here is the negative effect ads have on the consumption of organic content. That has already been shown. Skippability, on the other hand, facilitates ad avoidance without abandoning the session, right? So a general expectation is that users will consume more organic content when they skip ads, and a higher rate of organic content consumption when users are exposed to skippable ads has been shown in a lab setting, right, by these people. What we see that users in the skippable long ad condition consume 0.38 quarters less than those in non-skippable short ad condition, right? So this is equivalent to a 9.5 percentage point difference in the video consumed. Now, 44.5% of users in the non-skippable short condition started watching the video which is lower than the 53.5% who completed the ad, indicating that there is some dropout in the transition from ad to video, right? For the skippable long condition, the users can start watching the video without necessarily completing the ads, as the ad is skippable in this condition, right? 20.7% of the users in this condition have started watching the ad, 14.1% of whom have reached there by skipping the ad. So this is what we see as the video consumption matrix, right? Also, if you see here, the video start rate is 1, right? And the fraction of the users decreases, surviving users decreases over the course of the video, right? So the fraction of users who reached each quarter of the video, if you look here, is significantly higher for control condition. Control is when you don't have any ad, then both the conditions with the pre-roll ad before the video. So this is for non-skippable short and this is for skippable long. What does it show? It shows that showing an ad actually results in substantially lower video consumption. So we do see ad avoidance happening at an aggregate level, right? Now, why this is happening, what is happening? So we actually dig deeper into the mechanism, right? So the pre-roll ad can affect the video consumption outcome in 2 ways, right? The first one is the intent. It can affect users' intention to even start watching the video, right? More than half of the users in either ad condition actually do not start the video, right? So if you don't like the ad, it can actually impact your decision not to watch the video behind the ad, correct? The second thing is ads are also video content themselves. So ads, you watch ad, that is also content consumption. As a result, consumption can affect video consumption at an intensive margin. You can also substitute because the utility that you wanted to draw from consuming a content is fulfilled by watching the ad itself. You don't really need to consume the video. So that can also happen. So together we hypothesize that the treatment effect on video consumption is fully explained by the treatment effect on 2 outcomes. First, ad consumed. It's a pre-roll ad. So how much ad you consume before the video consumption and the video start, whether you choose to start the video or not, right? So to test this hypothesis, we can examine whether the residual variation in video consumption is significantly different across the 2 conditions, skippable long and non-skippable short ad conditions, when accounting for both the variables that I mentioned, ad consumption and video start, right? So to do so, we first regress video consumption on ad consumption, right? And video start to obtain the residuals. Once we have those residuals, we then regress the residual variation in video consumption on our treatment variable. And what we see that this finding suggests that the treatment effect on ad consumption, it's not statistically significant. That means ad consumption and video start fully explains the treatment effect on video consumption, right? Now, as we dig deeper, ad consumption is, what we do is we further investigate the relationship between ad and video consumption. So one approach is to regress video consumption on ad consumption to see how the 2 outcomes are linked. However, the main issue here is what we call as endogeneity, that users can self-select into how much they consume an ad, causing well-known selection or endogeneity bias. So we need to use an approach that only uses the exogenous variation in the ad consumption. Now our treatment variable, because we are just putting, everything is randomized. So our treatment variable provides a fully random exogenous shifter for this purpose. As a result, we can instrument ad consumption with our treatment variable and isolate the causal effect of ad consumption on video consumption, right? So we use a 2-stage least square estimator, where in the first stage, we regress the endogenous variable ad consumption, which is here, right, on our instrumental variable, which is treatment, by estimating this model, right? And then we use the estimates of this model to estimate ad consumption and obtain ad consumption to plug in the second stage model as follows, right? And we are interested in this coefficient, which is beta 1, right? So if you see here, we find that a 15-second increase in ad consumption reduces video consumption by 0.42 quarters. So the sign is negative here, right? Which is equal to 10.52 percentage points. So there is a substitution effect in play here, right? So average length of videos is around 2 minutes or 120 seconds. And if you do a back of the envelope calculation, 120 into 0.1052, so it's 12.62 seconds on an average. So every 15% second increase in ad consumption decreases video consumption by 12.62 seconds, which is almost a substitution. So if people consume more ad, they reduce the video consumption. Now that's where the challenge or the tension lies. If a user coming to your platform is watching ad, they're not consuming your content, right? From a platform perspective, this substitution pattern highlights an inherent trade-off in optimizing ad and video consumption. This, at the aggregate level, strategizes that increased ad consumption come at the expense of video consumption, right? Now, does it happen for everyone, right? Is everyone substituting video with ad, right? So what we do is we leverage a lot of covariates, yeah, and we use causal forest, because if you have too many variables or features or covariates and higher dimension, causal forest is a reliable estimator to estimate conditional average treatment effects, right? So the covariates are pre-treatment variables that I mentioned, which also include latitude, longitude, time of the day, day itself, right? And we capture all these as pre-treatment variables. And we use 10-fold cross-validation to tune the hyperparameters of this causal forest. What we see from the ad consumption perspective, so if you see here, this is Kate for ad consumption outcome, how it varies across individuals, right? And what we see, so we see there is an extensive variation in the case estimates. The sign of all the units still remain positive, even though it varies, right? So the utility that users can derive from ad consumption varies, but everything is positive. So skippable long ads results in greater ad consumption compared to non-skippable short ad formats for all individuals in our data, right? And it's significant for 97.43% of the users, literally all, right? Overall, there is no user whose Kate estimate is negative and significant, right? So people who are given a non-skippable short ad, they actually consume more ad, right? So if we use this sole objective for designing a personalized policy, the resulting policy will be a uniform skippable long ad condition for everyone, right? Because everyone, if you show them a skippable long ad, 97.43% of the users are likely to consume more ad than if you show them the counterfactual, which is non-skippable short ad. But this will only happen if the objective is you want to increase ad and you don't care about the video content. But that is not how platforms operate. Platforms want to balance both, right? Now, if we use, so as I mentioned, you have to really show skippable long ad to everyone. Now let's move and see what happens to video consumption. Again, using causal forest, we have Kate estimates, right? And although majority of Kate estimates are negative, there is small 3.15% of users who have positive Kate estimates, right? But if you consider the significance, only 3 users, which is less than 0.1% of total users out of these have positive and significant Kate estimates, whereas 55.13% of these rest of the 97% users have negative and significant Kate estimates, right? Now, if you just focus on this one, what you will say that with respect to video consumption, the objective is very straightforward. You assign everyone to a non-skippable short ad, because otherwise there is substitution happening, right? So if you look here, the prior results that I showed you through Kate, it showed that the optimal policy, if you just want to focus on ads, is showing everyone skippable long ads. If you want to maximize video consumption, the optimal policy is non-skippable short ad. But you want to optimize on both ad as well as video consumption. And that will lead us to actually plotting both gates together. Gate of video consumption, gate for ad consumption. I can see a question here. How do you interpret the results heterogeneity of all covariates as in, what can be done? So there is an interesting blog post on how to interpret and to dig deeper into the results of causal forest. Although we find substantial variation in the heterogeneous treatment effects on both ad and video consumption outcomes, the substitution pattern persists even at the individual level. Right? So what we are doing here, we are actually plotting the gate on video consumption here and gate for ad consumption here, and we present the resulting scatter plot. Right? So the broader question we are trying to ask here is, to what extent are gate estimates for these two outcomes in conflict at the individual level? Right? Since we want higher gate estimates for both, right, at the individual level, we want a more positive correlation between these gate estimates. But if you look here, only for a smaller portion of units, that is individuals, do we have the same sign for gate on both outcomes. What does that mean? That means that people, if they watch more ad, they're likely to watch less video. And that is not something we want, right? On the other hand, a negative correlation between these gate estimates indicates that a higher gate for one outcome is associated with a lower gate for another outcome. Right? That's what we see here, right? Thereby making the multi-objective solution even more challenging. There is a weak positive correlation between gate estimates. Correlation is around 0.13. Although the positive association between these gate estimates is not strong, it is still promising, as it suggests that gate estimates move in the same direction on an average, right? Intuitively, points that contribute most to higher ad consumption have a more positive or less negative impact on video consumption, right? So if you look at the platform here, scatter plot here, what it suggests is multi-objective personalization can be useful for a platform that really wants to simultaneously achieve both higher ad and video consumption, right? And that is our next step and the last phase of this paper. So what we do here, in order to define a multi-objective personalization framework, we formally define our problem. If you remember, at the start of the presentation, I mentioned that our framework, we assume, is also applicable in any setting where there is conflict between different objectives, right? So we formally define our problem. Then we present two algorithms. One is a greedy front algorithm, and then there is a parameter agnostic scalarization technique. After that, we do a counterfactual policy evaluation. What does that mean? If I assign this policy to this individual, the policy means, say, a skippable long ad, right? What would happen if I would have assigned a non-skippable short ad to this individual? And then we can see the difference between them. So that's the counterfactual policy evaluation. Finally, we also have to evaluate these performance of these different multi-objective personalization algorithms and suggest which one performs better, right? So in this last phase of this study, we do all these four. Now, problem definition. What we are trying to do here is we are defining a policy pi that maps from X, which is the covariates, to W, right? And which is the treatment space. So given all the features of an individual, what should be that treatment to be assigned to a set of individuals? And that's known as the policy here, right? So for any vector of covariates, the treatment prescribed to the policy is going to be pi xi, where I stands for each individual. Now for each outcome y, and that outcome is both ad consumption as well as video consumption, we define the performance of the policy in terms of an outcome as a mapping, rho y, right? Where this is the space of all possible policies, whatever can be assigned, right? And this indicates that for a policy pi, the performance in terms of outcome y is characterized by rho y pi, right? And this is the expected value of how this y, which is the outcome variable, will behave given if you assign it a policy pi, given a set of covariates, right? And that is what we are calling as rho, which is performance in terms of outcome y for a given set of policies, the expected value, right? After that, the third definition is we are looking for a Pareto optimal policy, what does that mean? We want a policy that if we assign an individual to that policy, right, there exists no other policy which will perform better than the one we have assigned the individual to. And how we can measure it? By using counterfactual. And we have a measurement metric that I'll define in next slides. So whatever we define is the best for that individual if the objective function of the platform is both ad as well as video consumption. So these are the three simple steps that we define here. Okay. First algorithm that we define is greedy front elimination. Very simple. What we do here, we have the Pareto frontier of the gate space are the set of observations whose gates are not dominated by any other observation. Okay. We further define Pareto rank or Pareto front layer, which is the Pareto frontier of the data points where once we exclude the Pareto dominating points. So what we mean by that? We mean by that is if we exclude the Pareto front, so let's assume this is the Pareto layer, right? This is the best. So all the points who are lying at this line, this is the best policy for them. What does that mean? For these people, their video consumption is high, their ad consumption is high. And we are going to assign them the policy that performs best for these outcomes. Why? Right? Then what we will do, we'll exclude these points, right? And if we exclude the Pareto frontier shown in the step function, the Pareto function for the remaining points is the second Pareto front layer. And we can exclude points in each iteration to obtain all the Pareto front layers, right? And all the Pareto fronts that you see here, it's of different color. So at a high level, what does this algorithm do? We can use these Pareto front layers to determine which points must be assigned to either treatment or control. Treatment is skippable long ad and control is non-skippable short ad. So the better the Pareto front rank, the greater the overall benefit of assigning these points to the treatment, right? If you see here, what is happening, the high level intuition behind this algorithm is the uniform control policy, and we keep on switching layers one at a time. If you see here, this graph, we have the Pareto front layer 25. So 1, 2, 3, 4, 5, and this is 25 that you see, this one, right? We choose all the points on this Pareto front layer and above, right? That is ranked lower than or equal to 25 to receive the skippable long ad format and the rest to receive the non-skippable short ad format. So if you look at this Pareto front layer, so all these will get a skippable long ad, but all these below will get a non-skippable short ad. And how we get there, as I was mentioning, you keep on removing one layer after the other and you rank them. That's greedy front elimination, right? After that, we also go for a parameter agnostic scalarization technique. What does it mean? You are just mapping multiple objectives into a single objective by weighting. This approach is also known as scalarization in the literature, right? And with this, what happens is the policies generated, right, are actually divided by a hyperplane. So if you are on this side, for example, this one, everyone gets assigned to a skippable long ad. But if you are here, you get assigned to a non-skippable short ad, right? Now, the problem with this approach is, as a multi-objective optimization, which is scalarization, policymaker needs to know the weights X and T, right? And in many problems, the outcomes have vastly different units, making this a priori knowledge unattainable. So you don't know what should be the weights Because essentially this is a line, and this line is drawn using a intercept and a slope. Now you have to ex ante know what should be that optimal slope, which is not possible in many cases. But the platform can use a variety of different weights and then trim the Pareto frontier of the full set. So more trial and error. As such, the algorithm we use is parameter agnostic. And the output of this algorithm is a set of policies that can each be evaluated by the platform. Right? Now, we have defined two different algorithms. As I said, the next step is counterfactual policy evaluation. Right? For those who get allotted to one set of policy, right, how they would have performed if they were not allocated this policy. So if this is an individual, and according to our algorithm, we assign this individual to a skippable long ad, what would this individual have done if it was not allotted to a skippable long versus to a non-skippable short ad? And how we do that? We use an estimator which is used very broadly in reinforcement learning literature, which is inverse propensity scoring. And IPS is model free. It does not rely on any outcome model to estimate the outcome under a given policy. And it uses actual outcomes from the data, right? And then weights them based on their inverse propensity score to consistently estimate what would have happened had the policy been implemented, right? So, and it also learns in batches. So it can also happen in real time. So because this is all programmatic advertising and all the bidding happens at the back end in real time. So if you go to a website, you see an ad very quickly in nanoseconds. So what we are proposing can actually be implemented by an ad exchange while the bidding is going on in real time at the back end, because everything is happening in batches, and the same algorithm has been implemented by vdo.ai to look for best policies. Now the results. Compared to the single objective personalized policy, that is, you either optimize only for ad consumption or you optimize for video consumption, right? There is a multi-objective personalized policy that we are proposing that increases video consumption by 47% while decreasing the ad consumption only by 13%, right? But if you want to focus as a platform on increasing video consumption and not on ad, there is a policy that increases ad consumption by 61% while reducing video consumption by just 4%, right? But you keep, so what we suggest here is, if you are in a setting where you want an individual to consume both ad and video, you do need to define a policy that has multi-objective optimization principle to it. To conclude what we just discussed, I show two common video ad formats: non-skippable short that are relatively shorter in length, 15 seconds, and then skippable long ads that are relatively longer, but users can skip them after 5 seconds. We run an experiment where we randomly assign users to both these ad conditions for an identical product, which is boat. We document a substitution pattern between ad and video consumption using randomized experimental data. So if you consume more ad, you are likely to consume less video. Although the skippable long ad format substantially increases ad consumption, it decreases the consumption of subsequent video. That's a substitution pattern. As a next step, we want to see whether this pattern exists for everyone. So we do heterogeneous treatment effects, which is conditional average treatment effects using causal forest. And we see that the substitution pattern happens even at the individual user level, controlling for all the pre-treatment covariates. Conditional on your IP address, where you are coming from, this substitution pattern is still there. Now, once we know that happens, we need to see what are the objectives of a platform. Platform wants you to consume ad and video, and that's where we propose two algorithms: greedy front and parameter agnostic. Using these algorithms, we define policy. And once we define these policies, We also use an inverse propensity score estimator to define counterfactuals. Now we know what will happen if you do this versus not this, and we test it across a random set of policies and also the policy we are defining. We see that a multi-objective personalization policy performs better. If you want to increase video consumption, use a policy that increases ad by 61%, reduces video just by 4%. If you want to increase ad, our policy using our algorithms increase video consumption by 47% and decrease the ad consumption by 13%. So that sums up this paper. Thank you for spending your time with me listening to this research. I hope it was of some value to you. Thanks a lot.
Thank you so much, Professor Kapoor. Really exciting work. As always, you have already a couple of projects in our center, and this is another fascinating work. And really loved, even after, like initially I was thinking it's a complex, obviously it's a complex problem, but then the trade-off, the final two that you are showing that you can get up to 61% improvement with such a small trade-off. That's something really amazing. I think every video platform would love to learn more about this. So thank you for sharing your work today. And I see there are some questions. Oh, no, I think just some comments here, but we can wait for a couple of minutes. Nikita, you have a question?
Yeah, can I ask you, do we have time?
Yeah, I think we can ask one question maybe, yeah.
Hi, sir. Very simple question actually. I was just wondering if all the people are being shown the same video content, or is the content different?
Yeah, so
Hello?
the content is different. Content is endogenous.
Okay.
Choose to watch because what happens is, just imagine you have certain set of websites that you watch or consume on a regular basis, say ndtv.com or any website. What happens is the content or the video that is shown to you is many times personalized for you, keeping in mind their cookie. But what an ad exchange can control for is what ad to show you, right? And that is what we are controlling for. But the video can actually be different for different set of users. But the length of the video is approximately the same.
Okay, so because my question was because sometimes the video content can be so vast. I mean, it can be for children or it can be for adults. So that's why I know maybe the randomization is done at such a scale that this thing might not make a difference. But still, I thought that would that be of any concern? So yeah, that's why.
That's a great point. So one thing we have done is the publisher that we are working with, that's consistent. Right?
Mm-hmm.
So the propensity of these being starkly different content is lesser, but we cannot completely rule it out. But assumption is, since it's randomized, and I haven't shown you the randomization checks, but we see that we don't see on observables any statistically significant difference between individuals and their observables across the treatment and control conditions. But that's a great point, yeah.
Okay. Thank you. Thanks so much for doing this webinar with us. Really exciting. Thanks. All the best for the paper coming up.
Thank you. And thank you everyone for spending your evening with me. I really, really appreciate it. Thank you.
Thank you, everyone.